Hey guys, welcome back with another math video, and if you're new to this channel, hello, Kara Tutoring is a free online tutoring service for low income students. So if you're low income and struggling with either or both parts of the SAT, check out the link in the description box below and apply if you compile by the guidelines. You'll be allocated to one of our highly qualified SAT tutors in which they'll help you get the score you want. So on today's video, I'm actually going to review a topic that frequently appears on the SAT, and I think familiarising yourself with this topic is important because it saves you so much time and effort during the test. Time management is really important, especially on this test. You should constantly be looking for like the fastest way to get to an answer and for shortcuts and stuff like that. Otherwise, you'll run out of time and that would be a complete disaster. So, our topic for today is special right triangles. So what is a special triangle? A special triangle is a triangle, both special features that make geometric calculations so much easier. So for example, if you're trying to calculate the length of a missing side, you wouldn't have to use the Pythagorean theorem or any other like trigonometric function. So cool, right? Alright, so there are two special right triangles in geometry, but I'm only going to review one of them today, which is the 45, 45, 90 triangle. This triangle has internal angles of 45, 45, and 90, as you can tell. And this actually results when a diagonal kind of like bisects a square. Like so. This is not accurate. Alright, so this is 45. And this is 45 too, yeah, which add up to 90 degrees. Alright, so how do I recognize this triangle come test day? Because I don't want to get it mixed up with any other triangle. Well, there are actually three ways. Number one, you'd be given two of the angles, which are like the 45 and 45, and this is the most obvious way. Number two, you'd be given only one angle, and this is pretty much the same. It's so easy because we know that the internal angles of any triangle actually add up to 180. So if we subtract 180 and if we subtract 45 and 90, sorry, my bad, from 180, that would give us 45, the measure of the missing angle. Alright. For number three, you won't be given any angles at all, but instead the length of the two sides. And in this case, the isosceles right triangle, both sides are equal in length. So if this is 7, this is 7 too. And we know for a fact that if two sides of a triangle are congruent, then the angles opposite to those sides, which are the base angles here, are also congruent or identical. So if this angle were x, then this would be x too. So 2x equals 90, x equals 45. Alright, so now that we've actually learned how to identify this triangle, what's so special about this 45, 45, 90 triangle? Like, what's its interesting feature? Well, this triangle has its sides in the ratio of x to x root 2, and this actually follows immediately from the Pythagorean theorem, and I'll show you how in a minute. But so that is the angle, the side opposite to 45 is x, which is either this one or this one, it doesn't matter really. So the side opposite to 45 is x, and the other side opposite to 45 is also x, which is this side here, and the hypotenuse, or the side opposite to 90 degrees, is x root 2. Alright, so how is this related to the Pythagorean theorem? Well, I'll tell you. The Pythagorean theorem tells us that if a squared, but first let me just name this triangle. If this is triangle, let's use a different color. Alright, whoops. If this is triangle A, BC. Then side opposite to A is A, the one opposite to B is B, and the one opposite to C is C. So the Pythagorean theorem tells us that A squared plus B squared equals C squared, right? But since B and A here are actually like the same length because it's an isosceles triangle, why don't we substitute A for B or B for A? It doesn't really matter because they're the same length anyways. So let's say A squared plus A squared equals C squared. Alright? That's 2A squared equals C squared. That's A squared equals C squared over 2. Then A equals square root of C squared over 2. And square root of C squared is C, so A equals C over square root of 2. And that's actually what we have in our ratio. If we multiply both sides by square root of 2, it would give us C equals A square root of 2. That's exactly what we've got here. So let me actually do an example for you guys to make sure that you actually know how to solve for this triangle. So what if I tell you, alright, so first let me, yeah, alright. So what if I tell you that side B measures 8 centimeters? What's the length of side C? Well, let's use our ratio for reference, of course. Well, if side B is 8, well, B could be either this one or this one, it really doesn't matter. So if this is 8, then this is also 8 because they're equal in length. And this is 8 square root of 2. All I did was plug in for x. You could use the ratio here if you want to. All you have to do is cross multiply. So 8 times x square root of 2 and then divide by x, so over x. And so x goes and cancels x, leaving 8 square root of 2. So the length of side C, or the hypotenuse, is 8 square root of 2. That's super easy. So let's kind of switch things a little. Whoopsies. So what if I tell you that the hypotenuse here equals, let's say, 10, for example? What's the lengths of sides A and B, or legs A and B? Well, let's use a ratio. So if this equals 10, so if x root 2 equals 10, what's the value of x? Well, so 10 times x over x root 2. Again, x cancels x, leaving 10 over square root of 2. And you could leave it like that, but that's, I don't like how it looks. So what we're going to do is we want to rationalize this fraction. And by rationalizing this fraction, I mean kind of removing the radical or radicals from the denominator. And we could do that by multiplying by the same radical. So if that's 10 over square root of 2, and we multiply both in the numerator and the denominator by square root of 2, that would give us 10 square root of 2, and square root of 2 times itself gives us 2. So divide by 2, that would give us 5 square root of 2. So x here equals 5 square root of 2. And I've actually prepared a question for you guys just to kind of test your knowledge. So I'd highly recommend you pause this video and challenge yourself, try doing the question, and I'll have the answers in the description box below. So this is the question here. Yeah, that's pretty much it for today's video. subscribe to our channel, hit the like button, and yep, hope you all have a nice day. Bye!